Good morning. I am Dr. Navina Priyadarshini, Professor of AC Department, Rohini College of Engineering and Technology. In today's class, we shall discuss about the radio frequency communication for industrial applications. So first, we shall discuss about the remote control and monitoring in industrial environments. First of all, introduction to the topic. So remote control devices, what are the remote control devices? They are the devices that can send digitally coded pulses to control functions like power, turn, switch off the devices, turning off or on the valves in industry, and to analyze the temperature, so the pressure, and to control the speed of the motor or to control the speed of the fan or different equipments in the industry from remote location. So for different communication mechanisms are used for the remote control and monitoring. First method is the GSM based home automation system. So in this home automation system, the each and every home appliances are IoT based systems that can be controlled from remote locations. For which access the GSM plays an important role. So GSM, which stands for Global System for Mobile Communications. So it is mainly uses the SMS services for communication. So the signal from the user to the home appliances, that would be this from the home appliances to the user, that would be sent through the SMS. So this offers the ability to control the appliances from all over the world, but the main drawback is there is no assurance of delivery of message. In case if during the transmission, if there is a loss in the data transmission, then there should not be any acknowledgement of reception of the data. So because of this drawback, it cannot be used as a real-time application for secure communication. So the second method of is the Bluetooth-based control system. So in Bluetooth is an IEEE standard. It is represents as IEEE 802.16. So it is another standard, communication standard that is used to establish the communication for remote applications. So here in Bluetooth, it uses the ISM band, so it operates in the frequency of 2.4 gigahertz band. So this ISM band is an unlicensed band, so anyone can access the ISM band. So all the devices will be connected through the Bluetooth in this ISM band. But the only thing is, Bluetooth has the coverage region of the range of communication will be very short. It should be, it has the capability to cover of around 10 meters. So it can be used for either in mobile phones or PC. So it can offer a control system for home appliances within the locality. So it can be suitable for real-time communication, and since it uses the 2.4 GHz of frequency band, it's a very high band, so the data rate will be very high. So it can give some alert messages to the users. The thing will be that it will be more trusted because it uses many security applications. So because of that, the data transmission will be very secure. But the thing is, the coverage range will be very short. So that is the drawback of this method. Next method is the dual tone multiple frequency. So it's a phone based system. So it uses the dual tone multiple frequency to transmit the commands from the user. So it makes use of phone calls for remote access of the devices. Number of devices will be connected through a single line. So it provides global coverage. Next, it can also provide real-time communication. So the drawback here is the number of devices that should be connected to the system will be limited. Next method is the ZigBee. So ZigBee is alternate technology. So the operation of ZigBee is almost similar to that of the Bluetooth. So ZigBee also operated in ISM band. So roughly it is around 2.4 GHz band as well as 5.2 GHz band. So since it uses high, you can see the speed of communication, that is the data rate will be very high, and it can be trusted. The remote devices can be controlled by this CB technology. The next RF transmitter module. So in all the cases, it consist of the RF transmitter module that is placed in the user side. So So the main components of these RF modules are the PIC microcontroller, voltage regulator, encoder, and the transmitter section. So the PIC microcontroller, it's said to be the heart of the operation. So the input messages that is collected and is given to microcontroller that will decide what the thing that should be done, and is given to the encoder for encryption operation, and then this is transmitted through the current destination. So these are the components of the RF transmitter. Next is RF receiver. So RF receiver, which consists of the basic components are RF receiver setup, decoder, the same PIC microcontroller, and the keyboard as well as the relay drive switch. So for the PIC microcontroller's operation, it requires the power supply. So the receiving antenna which receives the signal, and the signal is decoded, and from that original information will be decrypted, and the PIC microcontroller will decide what's the destination location and what's the command that is transmitted from the source, and accordingly the relay switch will be enabled, and it may be operation should be performed. So for example, the transmitting end, we need to turn on the valve that will be transmitted. So in the receiving end, the PIC microcontroller, it will decode the message that to turn on the valve number 2 means it will alert the relay drives of switch 2, and that will make the valve to be get open. So the actuator acted to that particular relay that will make the valve to open. So likewise, the communication will be established in industry. These are the basic components, that is decoder, PIC microcontroller, RF receiver, relay, loads, as well as the oscillators. Thank you.